In example 3, we've been given the equations of the asymptotes of the hyperbola. So we have slopes of 1 over 3, and it's going to be y equals 1 over 3x plus 4, and y equals negative 1 over 3x plus 2. So I've drawn the asymptotes in here. So I've sketched them in. And we've also been given a point on the graph of 6 root 3 minus 3. And that's the x-coordinate, and the y-coordinate is going to be 7. So I've kind of estimated here. What we really need to know is if this point is on the left side or right side of that asymptote or above and below. So we need to determine, is it in the position that I've drawn it, or is it in this position here, which make this trans x? The other position here would make that trans y. So we need to determine the location of that relative to the asymptotes. So I'm going to take the x-coordinate and I'm going to estimate that value so that we have a number to work with. And we know that's going to be at 7.39 and 7. Now that's really close to the asymptote. So we have to establish that. The other thing we have to figure out is that the ratio of B to A is going to be 1 to 3. And I'm just going to write that in here. So the ratio of B over A is going to be equal to 1 over 3. And again, that does not mean that B equals 1 and A equals 3. We just know that they are in proportion to each other. So the first thing is we need to determine the center of this expression, of this hyperbola. So we're going to find the intersection of those asymptotes. So I'm going to make the equations equal to each other. So 1 over 3x plus 4 is equal to negative 1 over 3x plus 2. Solving this equation, I get 2/3 x is equal to negative 2. So I end up solving for x. X is equal to negative 3. Plugging that back in for y, y works out to be positive 3. Okay, so the coordinate here is going to be negative 3, positive 3. And so I have my equations here. It's going to look like this. X plus 3 squared over a squared minus y minus 3 squared over b squared. And we don't know if it's trans x or trans y, so we have to write plus minus 1. Okay, so we need to really figure out if it's trans x or trans y. So we need to establish if that coordinate is either above or below that line or left or right. And to do that, we're going to compare that to the line y equals 1/3 x plus 4. So the easier number to work with is y equals 7. And what we can do is we can plug in y equals 7 into the equation and see what the x-coordinate on that line is. So when we solve for x, we're going to end up with it's going to be 3 equals 1/3 x. We get x equals 9. Okay, so the x-coordinate on that line is going to be 9, which is right about here. The x-coordinate of that blue dot is to the left of that line. So that means it must be to the left of that line, which is in the trans y position. So I've given you a little bit better diagram here where I've drawn it on Desmos. And you can see a bit more clearly here when we look at this. Okay, so we can see that at y equals 7, so this green line is at y equals 7. We can see that where it hits the asymptote is going to be x equals 9. Well, the coordinate that we need is 7.39 for x, and we know that that coordinate is less than the coordinate on the asymptote, so it's to the left, so it's in that section there. We can also do this with the x-coordinate. The x-coordinate is approximately 7.39, and we plug it into the linear equation of the asymptote of that blue line. We get y equals 6.43, and again, 6.43 would then be less than the y-coordinate of the point, which is 7, and so we can say that the y-coordinate of the point is above that asymptote line, and again, that our conclusion would be that it is trans y. So in either case, it's trans y. So we now establish, based on analyzing that coordinate relative to the asymptote, by doing that, we've now established that this is trans y. Okay, so I'm going to say that x is less than 7.39. I'm going to write in exact values. 6 root 3 minus 3. Okay, so that means that our conclusion is trans y-axis, and we're going to choose the negative version of that. Okay, so the last thing we need to do then is to set up a ratio to solve. We'll use a ratio to solve for either b or a, so we only have one variable in that expression, and then we can solve for that variable. So in this case, I'm going to solve for a, so I'm going to rearrange this equation here, and I'm going to end up with 3b is equal to 1a. So I'm going to replace the a's with a 3b, so I end up with my expression now that I'm going to use to solve is going to look like this. X plus 3 squared over 3b squared, so I replace the a with the 3b, y minus 3 squared over b squared, and that's equal to, since we've established a trans, it's negative 1. Okay, so again, I'm going to highlight that negative 1 because of we've established that it is trans y. Okay, so solving for b then, we're going to plug in the coordinate. It's going to be 6 root 3 minus 3 for x. So my calculation is going to look like this. 6 root 3 minus 3 plus 3. And that's going to be all squared over 9b squared minus y minus 3. Oops, I'm going to plug in for y. Y was equal to 7. So we end up with 7 minus 3 squared all over b squared equals negative 1. Okay, I'm just going to draw a line to separate that all. And then working this out, the 3 minus 3 and plus 3 cancel out, so we get 36 root 3 squared is 3 over 9b squared minus 4 squared is 16 over b squared equals negative 1. Multiply through by the lowest common denominator, and we're going to end up with 108 minus 9 times 16 is 144 is equal to negative 9b squared. Okay, we end up with negative 36 equals negative 9b squared. B squared equals 4. So we get b equals plus minus 2, and that means b equals 2. And then from above, we know that b is equal to 3b is equal to a. So solving for a is equal to 6. We now have the a and b's that we need, so we can just plug this into our equation. We end up with x plus 3 squared over 36 minus y minus 3 squared over 4 equals negative 1. So this represents the equation of the hyperbola that fits the description that we were given above. And again, if we take a look at the graph of this, we can see that if we graph this, there's our point. Okay, that's the point that we've been given. Those are the asymptotes. And if we sketch the graph that we came up with, we can see that that definitely is trans y. It goes through that point, okay, and it follows the asymptotes nicely.